Victoria's importance to the lives and livelihoods of East Africa cannot be overstated. This lake drains the watersheds of 5 countries, forms the source of the Nile, and provides sustenance to millions. This is the world's largest freshwater fishery. Over 100,000 fishermen and farmers harvest 1 million tons of fish from Lake Victoria every year, feeding tens of millions of people. But the state of this fishery has become precarious. Algal blooms and water hyacinth create anoxic conditions when they decompose, contributing to recent fish kills. And these algal blooms are fertilized and exacerbated by sewage discharge from the basin's urban areas like the lakeside city of Kisumu. My work this summer with Professor Charles Midega of Poverty and Health Integrated Solutions focused on 3 circular economy projects to transform these waste streams into valuable agricultural inputs. The first project harnesses the nutrients from human urine to make compost. Urine is rich in the nitrogen and phosphorus that microbes need to decompose high-carbon crop residues, like corn stalks, into compost. When the compost is mature, it can be used as a soil amendment to improve organic matter and fertility, but even before then, it can be used as a medium to grow crops in, like kale. This growing system is particularly promising in circumstances where fertile soil is unavailable or contaminated from mining and industrial legacies, which are common in slums where household sack gardens are widespread. The second project also uses the nutrients from human urine, in this case to make a standardized fertilizer for agriculture further afield. When organic materials are pyrolyzed, or burned when oxygen is largely excluded, a substantial amount of the carbon is left behind as charcoal. This product, called biochar, is porous and has an extremely high surface area. If the char is quenched with urine when it is red hot, the nitrogen from the urine bonds with the pore surfaces to make a nutrient-enriched soil amendment that Professor Midega's trials show performs well as a fertilizer. The third project I got to work on this summer focuses on the poultry feed value chain. Conventionally, the protein in poultry feed comes from fish meal. Fish meal is made from wild-caught fish, is expensive, and is contested by other demands for fish in the food system. Our preliminary survey of poultry farmers showed that the cost of feeding is the greatest constraint to production, so we are investigating if we can formulate more economical feeds by replacing fish with insect larvae, specifically by using the black soldier fly to convert otherwise burdensome market wastes to high-value protein. In the Lake Victoria Basin, the connections between land and lake go far beyond fish and the poultry feed. Nutrient flows from rural agriculture to urban diets and sewage threaten the lake's fishery, jeopardizing the sustainability of both the land and lake systems and the prosperity of those who depend on them. When these nutrients are managed through circular economies that return them to agriculture, the land will be greener and the lake will be cleaner.